morning, everyone. Welcome to today's webinar hosted by Numerical Analytics. Since we are aware that these webinars are recurring webinars and we have already completed the basics of functions and the inverse functions of it, inequalities. So moving forward, today we are going to see the inverse and the composite functions, which will be taken by Mr. John Paul. Over to you, sir. You can start with the webinar.
Sure. Thank you so much. Am I allowed to share the screen? Is it on? Just a sec. Good morning, students. Well, I'm trying to figure this thing out. Good morning, and good to see some familiar names again and again and again. Just a reminder, I also see one of my students here. Just a reminder, this is for grade 9 specifically. And so we are going at a different level altogether. Grade 10 is, okay, it might just be a repetitive or there's, never mind. It's exclusive only for grade 9. Those of you who joined us, who've been with us, let's for some time regularly. You've been here regularly, okay? Ever since we've had this webinar. Can you guys show me your hand? Raise your hand. Let me just see the hands of people who've been here regularly for the last, I don't know, 2 weeks. I have lost my count. I can see the name Aniruddha Reddy. Daita Dhruva. I'm not sure whether I recollect the name. How many of you can raise your hand and tell me that, yes, I've been here? Oh, you can't do that thing in this forum? There you go, Aniruddha's name. I've been here before. Okay. Harsh and Hitesh, I don't know who they are. Sai Sriya, first time I'm seeing that name, but welcome. Have you been here before, Sai Sriya? Sai Sriya. Not really sure. All right. Let's begin. We've been doing something, and the idea I keep asking is because sometimes I make a reference to what we did in the previous webinars. Today's agenda, of course, is composite functions, inverse functions, and then depending upon time, we'll touch on asymptotes and transformations. At the outset, I just want to make something clear. It might be a little theoretic today, meaning, what and why kind of questions, as opposed to what I really like is problem solving. Because constantly we're focusing or trying to focus these webinars on where the calculator is used, especially TI Nspire syntax, and therefore we're not looking so much into paper 2 kind of questions where the calculator is not allowed. Paper 4, and like I said, hopefully at some point in time we might even do something with the paper 6, which is a totally different ball game. So keeping that in mind, composite functions and inverse functions, I think it's important to understand the theory. At the same time, I said, even though I go a little theoretic today, I still have, as I always do, I still have questions from the past papers. Okay, not just, I'll make up some questions, when I'm explaining the concept, but just to reinforce the idea, like part B is a composite. And then, you can see that that's just one part, 2 points. So actually, technically speaking, when you look at composite functions or inverse functions, you may not necessarily find a lot of that. So try and understand, when I have examples from the past papers, it'll be very difficult to pull out like 10 different questions on composite functions. So I have to make up my own questions, all right? And in terms of theory of composite functions, in paper 4, it's limited in scope. Maybe paper 6 will have a little bit more. And definitely if you ever do something like an IB or something, so the knowledge of composite functions, the understanding of the theory behind composite and inverse functions, probably you'll get to see the full depth, the full significance of its understanding only when you go to grade 11. However, it's great to understand the conceptual understanding of composite functions and inverse functions, even in grade IGCSE. But just to give you an idea that, you may not necessarily see those kind of questions in the past papers, However, like I said, I will explain the concepts. I always go conceptually. I always believe that, students should understand. And if you understand, you will never have to remember anything. That's my basic thing. I keep telling all the students, focus on understanding, focus on the understanding of the concepts. And these are the conceptual understanding that, that really helps in something like a paper 6. And maybe sometime we will do something with functions and, paper 6 kind of issue. But our examples from the past papers today that may not be so conceptually driven is all I'm trying to say. Our examples may not, that's not a lot conceptually. However, these questions are not necessarily The next one, the C, not necessarily related to composite functions. The D is not related to composite functions about range. There's an inverse, but okay, we'll look at the inverses also. And another example I've pulled out, again, you can see it's a very similar question, not conceptually driven, but that C is interesting. That's interesting. It's an interesting combination. So before we start looking at the problem solving, I've got two sets ready for you. One is this problem set 1 and problem set 2, depending upon time, because I like to solve problems with them. I don't just want to go and solve it on my own. And there's a nice example here on trig, a trig function, that is, okay. So I kept that as an extra. As far as we are able to go complete what we want to complete, then we can go and look at the problem set 2. Our focus, as I put on the agenda, is composite functions and inverse functions, understanding the theory behind it. And if there is any time left after we have solved those examples from the problem set 1, then we'll take a look at the other bits of asymptotes and anything to do with transformations. Again, transformations is, while it is there mentioned in the syllabus in a very subtle way, when you hunt through all those questions in the past paper, very rarely you'll find that. Just like I talked about the theory of composite functions, the theory of transformations, not just a theory, I would say a lot more of transformations you'll see only when you come to IB. All right. So time permitting, we'll take a look at it. Our main focus is that everyone understands and how solves things that are pertaining to the IGCSE. If at a future time we want to do something that is more with IB or more with the theory, then we can dwell into that. So forgive me if I'm going to do a little theory today, but I've given you the plan, the agenda, that I want to do composite functions, I want to do inverse functions, and my focus is that you should not just understand but how you apply. And our application has a limitation based on the IGCSE questions. So I'll try and make some questions so that we understand the composite. Okay? Is that clear? Having said that, anyone who's in grade 9, it's only a grade 9 student, I want to speak up, you to speak out. What is a composite function? Oh, it's showing somewhere else. I'm writing. This is a problem with the sync and the Wi-Fi that's been, now is it marking? Again, it's marking something else there. Never mind. Something wrong with the sync factor within my laptop and my iPad. Anyone can tell me from our group here today, the grade 9 kids who are here today, what is a composite function? What do you understand by a composite function? Don't feel shy. In my class, I never say right answer, wrong answer. I just like to have discussions. So tell me, what do you understand by composite function? What is a composite function? Anybody, please speak up. Or write it on the chat if you're too shy to speak up. Daksh. I like that name. Can you tell me what's a composite function? Why is there so quiet? We never learn when there's quiet, man. If there's learning, then people have to talk. Otherwise, it's just one way. I have not yet learned about it. Okay, thank you. Anyone who's learned? Daksh, have you learned? Have you done this thing in your class? Hitesh? Sai Sriya? Nope. Daita? All right, then let's learn. Okay, so this composite functions, let's talk something about the algebra functions. Okay, algebra. What do we mean by algebra functions? Algebra is when you add and subtract and divide and all that kind of stuff, right? So earlier we have seen a function. Let's take an example of a function like, let's say, square root of x, and another function. Let's take let's call it with a different letter, g of x as let me call it a quadratic, x squared minus 3x plus 7. Okay, so you have a square root function and a quadratic function, two functions. What do we mean by algebra of functions is when we add, what is going to happen when we look at a new function, which is something like this, fx plus gx, a new function, addition of functions. Or it could be a subtraction, a new function. Another algebra could be multiplication, fx times gx. What will happen then? It's a new function, so obviously it should have a new graph, new features, new habits, new taste, everything new, correct? So this is what we mean by algebra. You can also have another one, let's call it J or K or P, I don't know, whatever you want, okay? So let's call it K. No, K is already done. Let's call it P of X is something fx ogx. I just wrote down fx ogx. All of you who said I have not done, I have not done, I have not done, just think about this third one that I wrote, okay? The third one that I wrote. First one, addition, subtraction. Second one, multiplication. The third one is division. Is there something that I need to be careful about when I've written the third one? fx ogx. Is there something that I need to be careful? We all have studied algebra, right? Is there something that I need to be careful when I write fx over gx? Should I be careful? Should I be even careful about something when I write fx over gx? Talk, 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 talk. I know you've not done, so it's good to learn today. That's why I said that it'll be quite theory today. fx ogx. Should I be careful about something? Should I be cautious about something? Gauri Shankar, Harsh, Hitesh, Sai, bolo. Kuch to bolo. I know you've not done composites, but this is just looking like a division. Should we be careful about something when we have a division? Wow. I just had a 2-hour class, man, and those kids started at 9 o'clock, AP calculus, and they were so much more talkative. Nobody? When you divide, let's say these are functions, right? When you have numbers, let's say there's a number A and a number B, or on the denominator, you have 0. Is it a problem or is it not a problem? Is it a problem if there's a denominator 0? Gx not equal to 0. Thank you so much, Gauri Shankar. Gx cannot be, because just as we see in numbers, this is numbers, just as we see in numbers, even in functions, the denominator cannot be 0. But there's something you need to understand. You know how Gauri Shankar said that Gx not equal to 0? What we mean when we say Gx not equal to 0, let me explain that, okay? What we mean. See, this is the same thing coming from numbers, okay? What we mean, it does not mean that Gx will never be equal to 0. It means that when Gx is 0, when means for the value of x that Gx is equal to 0, that value of x when Gx is 0 is not allowed here, is not allowed in the domain, not in the domain or the input. So when you see that thing written, it does not mean that Gx is not equal to 0. Gx can be 0. It's a quadratic. It's a quadratic. But Px, in the domain of Px, Gx is not, the 0, the value of x where Gx becomes 0 is not allowed. Okay? So with that in mind, let me tell you what's these three new functions that we defined. What do we mean by new? You know what? Let me explain that from here. Fx was a function, square root of x. It has its own domain. It has its own range. Gx is a new function. It has its own domain. It has its own range. Now there's a new function h. H will have its own domain. H will have its own range. And that may be the same thing as f. It may not be the same thing as f. It's new. So the input values are new. So the theory is so important to understand, because in functions, you know what is a function value? It's input equals output. So you got to be so careful about the domain. And so when you understand P this way, when I said in the domain of P, this value of x is not allowed where G becomes 0. Let's illustrate it, shall we? Shall we illustrate it, okay? So Gx, let's see where it becomes 0. That will help us review something about our graphs. Okay, Gx, we made it a quadratic, and I just hope that, I just made this example. It's not, I just made it up. So let's just hope that it becomes 0 somewhere. Can Can anyone work it out algebraically and tell me where do you think gx becomes 0? Wow, that's not a... Let me just put it on the graph and check, okay, for you guys. So I am, for today's lesson, because it's more theory, I will use the CAS, all right? So don't worry about it. When it comes to problem solving, we'll come and use the non-CAS version. But because it's theory and it's composites, deliberately I'm going to use the CAS. I'm going to try and show you, even if you're not using the CAS, there are certain things that you can really learn. I use the CAS more as a learning tool and not more as what is allowed in the exam. Okay, so the CAS is a algebraic supporting system, computer algebraic system, and especially when you do composite functions and classes, I teach using the CAS so that students understand and I'm able to check their answers, not just related to the exam perspective. All right, so we'll look at the CAS today. I'm going to graph this function that I made up. I just completely made up. So, if there is no 0, we'll have to adjust the 0. X squared minus 3x plus 7. Oh, there you go. There is no 0, right? There is no x-intercept. So let's pull that graph. Can you pull that graph? There you go. Oh, there you go. Oh, it's become inverted. That's all right. Never mind. Never mind. Let's keep that here. Let's bring our graph here. And it made up some numbers here. Let me make it some friendly numbers, okay? Let me make it friendly numbers. I will keep it as x squared. Watch, this is how you can manipulate graphs also, okay? So even though we are looking at composites, you can learn a little bit about how this calculator can manipulate stuff. And let me just make it 2. And let's make this 3 so that I can make it all integer coefficients. Oh, it's still gone up. Yeah, let's just change this one to say 8. Okay, that's better. That's better. It's a quadratic, as you can see. X squared plus 8x plus 4 is a quadratic, and it is becoming 0 at 2 different values here. It's becoming values at 0 at 2 different values here. All right, those 2 values of x. Let's find out what those 2 values of x are. Okay, let's use a trace to find that thing out. Graph trace. And let's just use the arrows, and there it's becoming 0 there at the value x is equal to negative 0.536. Negative 0.536. Okay, the function it has a 0. All I'm trying to say is that this quadratic has a 0, and if I go back to the other 0, okay, let's take a turn, come back here. Ooh, this long turn. Okay, come back here. Ready? What's going on? My tapping is a little... There you go. That next one is negative 7. Can you see there are 2 values where it becomes 0? All I'm trying to explain right now is that gx may be 0. It can have a 0. When you write that statement, gx is not equal to 0, it means that where it becomes 0 in those 2 things, it was something like x equals negative 0 point something. That value, 0.7, whatever, that value is not permitted in the domain for p. Is that clear? Everyone okay so far? Okay so far? Just give me a thumbs up if that is okay. The domain is critical. All I'm saying is domain is critical. Everyone okay? Just give me a thumbs up. Give me a smiley. Tell me, yes, I get it. Nobody got it? Domain is critical. Daita, Gauri Shankar. Everyone okay so far? Aniruddha, so far so good? Domain is critical. Alright. Yes, no? Kuch to bolo. Good, thank you, thank you. Now, in the same way, remember we are looking at algebra. In the same way, algebra is combining functions, f plus g, f minus g, f times g, and f over g. There is a new kind of combination, a very new kind of combination. F of g. That's a different kind of a combination, where the input of f is the output of g. The input of f is the output of g. What does it mean? Let's illustrate it again. All right. So you have the domain, one set of all x values. It goes to something called g. There you have g of x. And all those values are then put to something else, a new function, that's f. So this is f of g of x. Why did I go through that input? and the output, the domain and the range. The domain of f must contain the range of G. This is the range of G. Okay, I hope this is very important to understand. The domain of f must contain the range of G. Only then can you combine and make up a function such as f of G of x. If the domain of f does not contain the range of G, guess what? You cannot combine. Anywhere else in this addition, subtraction, multiplication, division, you don't have that clause. The division is just that one little thing that where it becomes zeros. But here you got to be very careful. The range of G must be contained in the domain of f. Only then you can combine. This kind of combination, this kind of an algebra of combining two functions is called composite functions. It's a very unique kind of combining, not adding two functions. Adding two functions, the domain will still be the intersection. But when you find the composite, my God, that's very different. The range of G must be contained in the domain of f. That's the theory. That's quite a lot of theory for today. All right. So let's try and put it into practice. Okay. In your IGCSE, you will be given some expression for f, like we took, root of x. I gave the example of G as some quadratic. I'm going to make another quadratic here. Let's call it 9x plus, let's say, 4. All right. Now, in that way, what it means is if you want to find f of G of x, how do we find it algebraically first? Let's do that. Okay. It means you have to write it as f of x squared minus 9x plus 4. Watch that. Okay, so what I've written inside is just the expression of G. It's f of G. Put it down there. Now the definition of f is that's input. All right, it means whatever is the input, this is what it means. Okay, f of an input, it means it's the square root of the term input. Square root of that's how we look at the function. Whatever is input, square root of the input. So now we will write this as, this is f of the square root of x squared minus 9x plus 4. So if you are asked to find algebraic solution of f of G of x, you got to write it down this way. You don't put an f there, you just put square root. That's why I said in order to understand composite function, CAS is what's going to help us. CAS is what's going to help us. Let's show it. All right. Let's show it using the CAS calculator. And then we look at our IGCSE question paper. So far, so good. Everyone, I'm going to show this thing on the CAS. All right. On our Nspire with the same example that I made up. And let's just check. Cool. Here we go. So how do we do that? How do we use a calculator like a CAS? And how do we use that to learn our composite functions? Okay. So here I go use the calculator page. And as we have seen so many times, how to define a function. I'm going to define and assign for f of x the same example that I had. I'm going to call it square root of x. There you go. I've defined. So far, so good. G of x is defined as, I can use the assign key again. And I can say this one is x squared minus 9x, as I'd said. And I have a 4. There we go. Right? Now we want f of G of x. F of, oops, let me type it again. F of G of x. Now remember, if you do not have a CAS, most of you have told me before who have attended that we don't use a CAS. What I'm going to do right now, you'll not be able to see it on your calculator. But I'll tell you what you can see. Okay, so if you have a calculator, we'll come to that part. All right, now hit enter. Can you see that? How cool is that? The same thing I did it by hand. And why is it important? Is because like we use it for learning in the class. Students can check their answers, they can verify their answers. And if I just tell the students, hey, f of g of x is equal to this, what do you think of g of f of x? If you reverse it, what would happen? They then use a calculator first. My students would use a calculator. Okay, let's just check g of f of x. What does that mean? What is it going to be? And they'll write down, oh, that's different. That's different. And then I'll ask them, okay, if that is different, let's use our paper and pen and check whether that is correct. So we come back to our paper and pen, and then we, using the same two functions, we write down g of f of x, the reversed, and see whether our algebra is doing the same thing that the CAS calculator is doing. Let's do the same way, okay? What does g of f of x mean? G of f of x means g And into the bracket, I must write down what is f, correct? I must write down what is f. What was that f? F was just square root of x, the way I defined it. Now remember input output, how we defined input. G of an input is equal to, how's G defined? It is input square minus 9 times that input plus 4. That's how you have to read and interpret the definition of G. Okay, when you see G of x as x squared minus 9 times x plus 4, it literally means whatever is that input, it's input square minus 9 times that input plus 4. So right now the input is square root of x. Right now the square root of x is the input. That's the input. So we write it as input square minus 9 times that input plus 4. Square root of x, the square is just x minus 9 root of x plus 4. That is G of f of x. So my children in my class would do it by hand, and they'll go back to their calculator, the CAS calculator, and say, oh, what is that? Oh, we got that. And they give a high five to each other. And they say, thank you, CAS. Now, I strongly recommend the CAS calculator for this reason, because you can check your work. You can check your work and you can be confident of your work. Any questions so far, boys and girls, who've been watching Composite Functions so far and hearing from me, because you've not done it in class?
So we have a question from Gauri Shankar in the chat box.
In the chat box, Gauri Shankar, first we need to check domain of f is a subset of G, or yeah, we need to check that domain. Yeah, thank you. Thank you for bringing it up. In this case, the root of x will be positive values only. I was just showing them the algebra. I think they will have that kind of stuff in the IB. Looks like Mr. Gauri Shankar is a teacher. Thank you. You need to check. That's why I highlighted earlier on. In this particular case, g of x, because it's a square root, yes, we need to check the domain. Is it even possible? Thank you, Mr. Shankar. I was basically only showing them the, with the IGCs in perspective, they don't go so much into detail, which I explained right at the beginning. The theory was important to explain, but I did mention about the domain contained and all. I just wanted them to highlight how it is to be used. But thank you for your input. Boys and girls, is it okay? Cool. Now, what we're going to do is that I'm going to go through one more thing, or let's do one question before we come to this, okay? Let's just go to our questions page. Otherwise, it'll be too much of theory, all right? I also don't like too much of theory, by the way. So let's come to our problem solving set 1 on composites, okay? And you can use your calculator now. You can use your calculator. Let's shoot with this, okay? So there are 3 functions given, f, g, and h. This is an IGCSE question paper. And I want you to find both 1 and 2 quickly, all right? Part A and part B. And then we'll look at part C. Questions on part C you might have done last time in the webinar last week. So we should be able to even that with NSOLVE. But let's quickly do A, B, and C. So B is something new. But I want you to use that assign key. All right. So I'm going to open up my non-CAS calculator now. If you have your calculators, please use the calculator to solve A and B. Remember, use the assign key, all right, to first assign what is F, what is H, G, and H. All 3 put it up together, and you should be able to crack A, B, and C. C is a review from last time. A and C are a review from last time. B might be something new. Let's try that. All 3, let's do it. The children are so quiet, I don't like it. B is 6. But I also like it when teachers are so enthusiastic here. Good, Mr. Gauri Shankar. I'm glad. My calculator is not opening. Kya ho gaya? Oh, there you go. If I can quickly share this thing. For those of you who are still wondering what's going on, you have to define, remember? Just define as you're seeing it. When you do it, you'll have the practice, and when you are trying to do it, you'll have the question. So we encourage you, do it right now. So if there's any issue, you can check. All right. So that's F, that's G. I'd encourage put it all together first. All the three ones, just define it. G is given as 5 minus 2x. Oh, you guys can't see the question, right? When I've switched. And H is x squared minus 3. H, if x is x squared minus 3. So I have an x squared minus 3. And there you go. The first part of the question was just to find g of negative 3. Okay? So you have to just put g of negative 3 and you should get the answer. That we've seen. And the second part, which is the which was the composite, is f of h. You have to just put f of h. And what was the value of 2? At 2. And you will get the value, as Mr. Gauri Shankar has said, it's 6. So I'll switch back to the question. This is again just a review of some of the basic tools that we've seen, but so that we can also practice. If you guys can just do the part C also, use and solve, please. Use and solve. X, find x when f of x is negative 10. Then we'll come to D and E, which is, you know, the range and the inverse. But before we come to inverse, I'll say something about the theory again. Part C is 6, part B is 6. Part C is a review from last time. Find the value of x when fx is equal to negative 10. Find the value of x when fx is equal to negative 10. When f of x is equal to a negative 10. Is it 10 or negative 10? What is it? Negative 10, sorry. If all of you recall, then yes, thank you. If all of you recall, okay, we can do it by hand, by algebra, you know, but because it's in the GDC section, you can use and solve to find that value also. All right. And we've seen this example earlier on. Write down the range of h of x. Write down the range of h of x. H of x is a square function, x squared minus 3. And to find the range, if I were to ask any of the students here, what is the range, by the way? How do you find the range? Any of the students? Any of the students? How do you find the range? My God, today is so quiet, man. Daksh, how do you find the range? Aniruddha, how do you find the range? Any idea? 1 sec, sir. Okay, 1 sec for you. Okay, range is Mr. Gauri Shankar here. He's right. I don't feel he's a teacher. Just confirm to me if you're a teacher. There's a difference between... Whoa. You know, Aniruddha, you're not wrong, but except that definition of range that you're using is in statistics. Okay? That's where we define range that way, that the difference between the... So I'm not saying that your answer is wrong. In my classes, never I say right, wrong, and try to put them off. That's why I said your answer is right, but if it was in statistics. Now, unfortunately, we are not doing statistics. We are doing... okay, in that sense, the range is a set of all y values. I thought I'd saved this page. I'm not sure where it's saved. Okay. किया तो है मैंने. So come back here, put the paint. No, this is not it. Just one second. Just bear with me for a second. Screen capture, that's not what it is. Where has it saved the images? Ready? Yeah, I think it's gone somewhere else. You know, all my screenshots are, I don't know where it's going. I'm trying to, I took a screenshot of my screen captures. You can, there it is. Mr. Gauri Shankar, if you're using your teacher software, this is a great tool to have when you're doing it online. You can take a screenshot of the thing. And students, if you're using the software, this is great for you also. You can take the screen grab when you're explaining to somebody. I took a screenshot of that thing so that we can see. And I was telling Aniruddha, it is the y values. Okay, my h is that quadratic. It's the y values. And so when you look at the y values that we have from what we have graphed, as you can see, the y values are all going. What are the y values of that graph? The y values are all that, right? Those are the y values. I'll use another color maybe. Those are the y values, okay? That's the range. The range is the set of all y values. So if you have not done in the class, range is the set of all y values. And clearly it includes -3, and it goes all the way to infinity. Okay, so that's how you write the range, all the set of all y values. From the graph you can see. Okay, and then let's look at inverses, because we were only interested in doing inverses today, composites and inverses. Before we go to inverses, just out of theory, because you know I'm big on theory, by the way. Okay, and what are inverse functions, where do they come from? And actually the theory is somewhere embedded in the composites. Okay, now as we saw in this example, f of g, when you take two random functions, f of g of x will not be equal to g of f of x. You know, even in our example, it was two different examples, right? See, g of f is x minus 9 root x plus 4, and f of g of x was something else. At random, when you pull out two different functions, f of g, the composite of f of g, will not be equal to the g of f composite. That's if it exists. Like Mr. Gauri Shankar said, you know, the domain of f must include the range of g. That is critical. All right, that kind of theory will be important when you do IB. Perhaps not IG as much. Okay, but I mentioned that in the beginning. It's a very important point, although. But despite that, normally you will not find f of g is equal to g of f. Normally. Okay, so hear me out, boys and girls. We are going to inverses now. When f of g of x is equal to g of f of x, and not just equal to anything, it must be equal to the single term x, single term, one single term. Whenever f of g of x is equal to g of f of x is equal to x, not like this, x minus 9 root of x plus 4, not like that, not three terms, one term x. When you have something like that, we say f is the inverse of g, and g is the inverse of f. That's the theory. That is the theory behind inverse functions. And like Mr. Shankar said, that you know why we are even talking about this, because it's the identity function, and I don't think these kids have done so much with the theory of identity functions. Y is equal to x being the mirror line. They've not done, and even in the IGCC, you know, not sure whether they've actually classified. But basically, what Mr. Gauri Shankar is saying is that if that's the line y is equal to x, it's like the mirror line. If you have a function f of x like that, then you know what? The inverse of f is going to be an exact mirror image. Exact mirror, a reflection about the line y equals x. Okay? Exact reflection about the line y is equal to x. Okay? And that is why it has to be equal to x. The composite must be equal to x. And that's the theory behind inverses. That f of g of x normally is not equal to g of x. Normally, you pull out two functions at random, it will not be equal. But when they're equal and they're equal to x, that because of that line y equals x, that mirror line, we say that they are inverses of each other. Now, what's there in your IGCSE syllabus? You have something to find an inverse, to find the inverse. And to find the inverse, we'll use a two-step method, okay? We'll use a two-step method to just find the inverse. What you do first is that you first interchange x and y. That means where you see x, you write y. Where you see y, you write x. Make sure that you write this in your paper. Huh? Either you write interchange that whole sentence, or you make sure that you symbol. So if your function was, let's say f of x is say x 4x plus 3. I just made up a function. And you know fx is y value, so that's y is equal to 4x plus 3. What does it mean to interchange is where I have y, I write x. So after you write this symbolic notation for interchanging x and y, you write it as x is equal to 4y plus 3. That's the first step. First step, interchange x and y. The second step is you make the new y, new, the new y, the subject of the formula. You make the new y the subject of the formula. So what is the new y? That's my new y. So, you isolate that new y and write it in terms of y. So what will happen? It will be y will be equal to x minus 3, the whole thing divided by 4. This new y is your f inverse of x. This new y is your f inverse of x. fx was 4x plus 3. F inverse is x minus 3 divided by 4. X minus 3 divided by 4. Let's check. What did we say in the theory? We said the theory was if f of g is equal to g of f is equal to x, then we say the inverses. Let's check. Let's check. That's f inverse. Let's just check whether the composite is true. Let's just check. So fx is, what is that? 4x plus 3. F inverse, we have just found out with this two-step method, is x minus 3 divided by 4. Let's check f of f inverse. What a theory class that has been. Composite and inverses. Let's just check. Let's check. So, remember input. Input, f of an input is 4 times the input plus 3. What does this mean? This means input minus 3, the whole thing over 4. Read your function that way. Input, output. So f of f inverse is actually f of x minus 3 over 4. The input is that term. The input is that term. X minus 3 over 4 is the new input for f. How is f defined? 4 times the input plus 3. 4 times the input plus 3. 4 times the input plus 3. But that can cancel, giving you x minus 3 plus 3. Hallelujah. We got x. That shows that the theory is right. Huh? F of f inverse is x. And that's how you find the inverse. Let me repeat that again. Interchange x and y and make y the subject of the formula. Let's go back to our question. Our question from that solving set. It says, find f inverse of x. Find the f inverse of x. fx was defined as what? 4x plus 2. Can you guys work it out? 4x plus 2. Similar kind of question. I called it 4x plus 3, but 4x plus 2. So y is 4x plus 2. Do not forget to write the symbol for interchanging, okay? I'll tell you why. If you just write this statement, if you just go from this statement to this statement, how can x become y and y becomes x? You please mention this, okay? That's part of the working, that you interchanged x and y, or write the sentence, okay? Interchanging x and y. Don't just jump from y is equal to 4x plus 2 and then write it as x is equal to 4. That's silly. You have to write down what you have done. X and y have been interchanged. And then make that algebraic statement to say y must be equal to x minus 2, the whole thing over 4. And that is the inverse of x. It's been fairly quiet. Nobody's talking to me. Nobody wants to talk to me. All right. But I'll give ourselves maybe 5 minutes to maybe solve this. Even if you're wanting to solve it quietly, do it quietly. A, B, and C if you can solve, because B has got a composite and C has got some algebra with a component. Can you see the algebra f of, I think it's f, yeah, it's f of g of x plus f of x. Okay, so 5 minutes, and then we'll have Q&A, and then I'll hand it over to Swati. Okay, try it out in your calculator. Function, part A is a review, part B today we've done on composites, part C is an algebra. I think there's a, oh, there's a D also, H inverse. So maybe you can do the H inverse also. Try A, B, C, D, please, on your own, using a calculator. We'll have a, yeah, I thought that was a question. Try this on your own, please. Meanwhile, let me see if I can grab my calculator in the background. Use the defining option, defining a function. Use the defining function option and solve A, B, C, D. First define f of x, g of x, h of x. Use your calculator to find those values. Good, Aniruddha. Good. But try part B also. I hope this session was helpful. We were able to do a lot of theory, and I did this thing for you on algebra. Also in closing, before I hand over, again, let me just quickly show you the usefulness of a CAS when you have something like this. All right, f and g are defined. Let me quickly change. I'll just change the definition for fn quickly. Just the usefulness of the CAS, So I'll just quickly demonstrate that also. So I have x squared plus 1 is my f. My g, I can redefine that as, what is that, 3 plus 2x? 2x. And I have been asked to find f of g of x plus f of x in that second part, which I have done algebraically already. And there's 5x squared plus 12x plus 11. Why am I getting it as 10 here? Did I write the question incorrectly? No, it's a good thing. I'm glad we did this. Why am I getting it as 11? 9. What's going on? 3 plus 2x. X square plus 1. F of g of x plus 1. सही तो किया है मैंने. F of g x plus f of x. 5x square. 12x plus 1. Why am I getting it as 11? There's some questions have come. F of 3 plus 2x. Where's f of 3 plus 2x? That's okay. What's going wrong here? Sir, can I see the question? One second. Okay, I'll show you the question. The question when I'm solving by hand is 3 plus 2x. That's okay. Is x squared plus x squared plus 1. I got the mistake. Fantastic. There's a 1 here. X squared plus 1. All right. This is this square plus 1. Very good advertisement for CAS. Excellent advertisement for CAS. This is what I think the CAS should be used for. And that means this will be plus 1 and equal to 11. Fantastic. Did everyone see that? I did this by hand, and it's possible. It's possible that you miss out on a 1. But then, when anybody, not just my students, but anybody, if you had a CAS with you, and if you just check it out, not this one, this is not the non-CAS, sorry. If you check it out, and you see that, hello, they are getting 11, why am I getting a 10? It makes you go back and check your work. Fantastic. Isn't that great? Everyone? What about my TI team here? Revdi, Swati, what do you think? Isn't it excellent? I mean,
Yes,
it was not, I didn't do it, it was not, मैंने जानबूझ के नहीं किया गलती, actually हो गया मेरे हाथ से गलती. But isn't it great?
It
That,
is like, you'll be more
when you,
confident when you have a CAS
yeah.
calculator.
Yeah, so students, I think, no matter what your teachers say, can I please see the 2 questions, please? Yes, Aniruddha, I'm so sorry. Aniruddha, when I'm asking Aniruddha to speak, Aniruddha doesn't speak. I'm just excited about the CAS right now. And which 2 questions are you talking about, Aniruddha? These 2? This one? I just got too excited about the CAS. But this is excellent. Fantastic. This is what I was talking about. You can check your answer. You can go back and rework in the class.
I just wanted to see the B question.
The B. Can you see it now?
Hello?
Yeah. Can you see it now? Can you see it now? Oh, am I sharing? Yeah, I'm sharing, right? Anuradha, can you see? यार ये बच्चा कुछ बोल. Can you see it? Is he there? Am I there? Is somebody there? Aniruddha, can you see? पता नहीं यार. Okay, with that I'll transfer I can hand it over to Swati. I'm not sure whether I didn't get. I cannot speak. Why? What happened? But did you see the question? Did you see the question, Aniruddha? Did you get what you wanted? Type it now. I don't like to keep anyone hanging. I cannot speak. Okay, Swati, over to you.
All right. Thank you, sir, so much for this wonderful session. So I hope you all have learned on composite and inverse functions. So now we'll be having a quiz on what we have learned today. So I request all of you to just log in your Google and enter joinmyquiz.com. Enter on your Google portal joinmyquiz.com. I'll then share the code with all of you. Okay, once you enter in joinmyquiz.com, please find the code here in the chat box. It is 764545. 764545. Joinmyquiz.com and then input the code 764545. Please join for the quiz. Is anyone else trying to join? Vishud, I don't see you joining. Can you please join so that we can start with the quiz? All right, let me just share the screen and we'll start with the quiz. Okay, share screen. Okay, here comes the first question. The inverse has been reflected over which line? We just learned this. Ten seconds. A very easy question. Yes, it is y equals x. Second question. You can see the function f, g and h. Find f of g of 5. You have enough time. So assign the values of f and g. Please don't just make a guess. Assign the values of f and g and then find the composite. One minute left. Use your calculator rather than doing it by hand. Ten seconds. Time up. Vishud is on number 1. So the correct answer is option 3, 92. The next question. What type of function is this? It's a very basic question, so I've just given you. Fifteen seconds. All right, the graph is an exponential graph. Fourth one. Again, the two functions are given. You need to find g of h of 1. The same. Assign both the functions and then just input what you have given. One minute left. Ten seconds left. Which of the following is not true about inverse functions? Read the statements. Not true. The question is not true. 10 seconds left. So the answer is option C. The domain of a function always becomes the domain of its inverse, which is incorrect. Alright, the sixth one. For f of x, the function is given. What is f of minus 2? You just need to assign f of x and then just input this expression. 1 minute left. Ten seconds left. Okay, so the correct answer is all right. Okay, we have completed this. Okay, the next question. Function is given. If the function is given above, what will the inverse function be? Inverse of this function. So as we know, we just need to interchange x and y variables. Ten seconds left. So it's option 3. Ninth question. How does mod x graph looks like? Just input this function in your graph and see how does it look like. The modulus can be found in math template, which is number 9, beside the number 9 key. Ten seconds left. It's option 1. Next, 10th question. What's the best description? So what kind of functions are these? Ten seconds left. Okay, so yes, they are inverse functions. 11th question. Which graph represents inverse over the same domain? So f of x is the image, and among the options find out the inverse for the function. Five seconds. So yes, it is option 2. Again, a composite question. G and K functions are defined. Find J of K of 11. One minute left. Ten seconds. Yes, it's number 2. Oh, option 3. Last 5 questions. F of x is given. You need to find inverse of 12. So this can be done using n solve. Yes, the correct answer is 7. The two functions are given. Are these the inverses of each other? The correct answer is false. What is the inverse function of a quadratic x square? Mr. John Paul had mentioned this. 30 seconds. Okay, so yes, it's a square root function. Next question. What, when finding the inverse of a relation, so what is the procedure to find the inverse? We had done this as well. The correct answer is solve for y, the first option. So the first option. The last question. What is the inverse of this function? So the function is given. Choose from A, B, C, D option. Yes, the correct answer is option A. So now seeing the results, on top we have Vishud, on number 2 we have Daita. Okay, so as we know that these webinars are recurring webinars, so our next webinar will be on 21st of November, which will focus on logarithmic and exponential functions. So thank you all for joining for the session. Thank you once again.